Good evening, everybody. So, first of all, let me give my thanks to Library and Lalu for inviting me here, giving this small knowledge about distributed database systems. So, as you know, distributed database systems is not new in the market. It has been there for a long period of time. Not that long, at least 10 years it took to mature to the level in which it can perform for big data systems. So what exactly is distributed database system and why it is used in the market, and how far it is used right now, and how Postgres can be coupled towards this architecture is what I'm going to discuss. So there are no case studies as such, but me and my company has worked a lot on this technology, from the naive stage, from started setting up in on-premise large data clusters, and now to large Postgres clusters in Redshift in Amazon Web Services. So as you may be knowing that Redshift is basically built on Postgres cluster databases using distributed database systems. Okay. Where do we use this data based technology, this distributed database management systems? So as you know, the data is growing very fast, in the sense that each and every room is monitored by sensors, movement is monitored by cameras, and enterprise systems are getting deployed across all the small, medium, and very large companies due to the digital transformation that is happening. The data is getting accumulated on a day-to-day basis on a very, very high scale, from gigabytes to terabytes to petabytes to exabytes. Those storage capacities, which we didn't even think of before, is possible now because of this distributed database technology, specifically for structured data systems. Okay, this unstructured is also part of it, but basically it is used for enterprise structured database systems. Okay, so where it is used? So it is basically used for reporting purpose, as a first thing. Historical analysis of large warehouses, large ERP systems. For example, if a country has got operations across, let us say, 120 countries with multiple languages, and they have a distributed transaction system like SAP, Oracle, or any other ERP systems, this data needs to be consolidated in some point in time to have a 360-degree view of a specific region like
Yes.
EMEA or Southeast Asia, Europe or Americas, Africas. All these regions, somebody needs to analyze it before taking a marketing decision or a new business division or a new product. Whatever it is, they need to know about what exactly is happening for their operations in those countries. So previously it was used as a localized systems. That means to say, if there is a reporting infrastructure in India, it is just going to be for that region or for that state, and people will be taking data from those localized systems or from that database and put it in their desktops and give the numbers to the senior managers. And somebody from the global level, they send all this data to them, and they consolidate it and give it as one single report. So this made very big problems because by the data moves from one system to another, it changes because the data types that is across the systems might differ. So one database will be in some other data type, other will be in another data type. So when it moves from one location to another location via email or CSV and imported, data will get lost. So that gave way to creating a distributed, massively parallel processing appliances. That is, systems which compute large volume of data in gigabytes and terabytes, and distribute this data across nodes and process it at one single place and give it to them. So there is single node architecture also, there is multi-node architecture also. So single node is something like shared nothing architecture, where you have one single server and you have multiple disks under that, and the Postgres or any other database engine will be hosted on that, and the data will be shared across these nodes using distribution or what is that called, partitions. And this data is called a single node architecture or symmetrical multiprocessing system. So that itself is somewhat big, but for these type of large volume of data, that itself will not cater to the needs. So then came up with this technology called as MPP, massively parallel processing systems, where you have multiple nodes. That is, each and every system will have multiple nodes or worker nodes under that, and there will be one control node which distributes this data across these nodes, and if somebody queries or insert the data, it will get distributed across these nodes, so that each data set will have a processing capacity of its own. It will have its own CPU, RAM, disks, and network connectivity, everything. And in between these nodes, it is connected using network, which itself will be high performance network connectivity. Okay, so just to give a small introduction to it, this is what MPP is, or distributed database systems for big data storage is. So how Postgres can be enhanced to that level is what I'm going to present. Okay. So what are the benefits? As I told previously, it is distributed data across the node. So data will always have a copy across it. You can even replicate the data across these nodes. For example, if you have one data which is needed by all the data, that is, if there are 10 nodes and each node needs a specific set of data, that is a currency. Now, this data can be replicated across these nodes so that any cardinality or queries needed between these nodes can be operated on those individual nodes. So the query execution time is so fast, it will retrieve all the data sets across these nodes within minutes, or within seconds. Okay. So the key challenges, I'll discuss about the challenges afterwards. And it has always got a fault tolerance and availability, because data is already available in multiple nodes. These nodes can sit in one location, or it can be in any multiple locations. It need not be necessarily one location, but the network should be connected between these two, and it should be mostly enterprise will allow only if it is in the same subnet mask or inside the network. So it can be in any location. You can spin multiple machines and connect it and distribute the data across. Right? And it allows you to do real-time analytics. That is one of the key things, because as soon as the data comes, you are querying from multiple nodes. So what we used to have with single node structures is bypassed, or it is solved with this MPP architectures. So large volumes of data can be queried across multiple people at a shot. We are not talking about small megabytes of data. We are talking about gigabytes of data, sort of a data warehousing or a big data engineering clusters. Okay. So these are the various definitions before we go ahead with this. And performance also, it reduces latency to retrieve the data. Now, sorry. So in Citus, we have extension which you can add to the Postgres and actually distribute the data. You can spin various worker nodes under various IP. You have to make the DNS setup, and also you have to have specific IPs for that, so that the data can be transmitted across multiple nodes. And you install the Postgres under each of these nodes, and you will have one single master node from where the queries will be distributed across, and it is network connected. So in modern technologies, this network plays a very important factor, because even if you build a very good or a robust infrastructure for this distribution, if the network between these nodes is not good, the whole purpose will go off. So one of the key things which we have to look at is the network. What is the speed of the network between these nodes when the data is getting transmitted or shared across these nodes? So it won't lose all the core features of Postgres, but Citus has got paid extensions also and free extensions also. So, but we will talk about the free ones here right now. And we have the coordinator and worker nodes also, which is the coordinator is the main coordinator. I'll show that in the next slide. So we have the coordinator node and the worker node, because the worker nodes are where actually the processing will happen, and the coordinator node actually manages that queries, manages the schema where it is where it is stored, which node it is stored. All those metadata information is stored in the coordinator role, and that is a place where somebody logs in and writes a query, and it distributes to that multiple nodes. Let me just move forward. So let us see an example of this. So you have the control node here, and it has got the compute and the storage down. Okay, the storage is all down here. So when somebody submits a query, it goes to all these storage locations, processes it, and brings back the result back to the control node, and the query result will be coming to the user interface. Okay, so this is the basic concept where you get the data. So you get the data by querying, but it will get distributed across these storage nodes, and it will return the result to the control node, and it brings back the result. So this is the basic concept, right? So if you write a query like select something from any of these tables, what happens is all these queries are executed at individual nodes, which has got its own database structures, and it has got its own storage layers. It has got its own VM, compute. Everything is part of each one of this. Okay. Now it returns the results from each one of these nodes and gets a total from it and gives the result. Now each one of these database is sitting under each of these worker nodes, and it is a parallel query execution. It is not a serial query execution if you look at it. So if this has got 1 million rows, this has got 2 million, it has got millions of rows in each one of this, the query is executed parallelly, because when it goes into reporting or big data analytics for AI/ML or any other advanced technologies, you need the query to be executed fast. Nobody waits more than 1 minute, no, not even 1 minute, 15 seconds in front of the screen to get the result. If you give some output to somebody, everybody wanted it within 10 seconds minimum. The number should come in front of you, right? So if the backend data is having like millions and millions of records, it is not possible from a normal database, because it will be choked. There will be a lot of queries running. It won't be one person that is querying. It will be multiple people querying. Multiple threads will be running into it. The cores will be choked, and you have to scale up the servers, and then the licensing cost goes up. So a lot of challenges will come when it comes to big data engineering or big data querying and reporting setup or analytics setups. So these type of architectures will really help in scenarios where there is a lot of data that is coming on a regular basis. Very simple example, when you go browse an internet like Myntra.com or Amazon, if you click on it, the data is pumped to the MPP architecture, MPP system on the backend. This is called as clickstream data. So you click where you click on that website or on your mobile phone, it is captured by the company on the backend called as clickstream. This data is streamed instantaneously to the backend big data appliance. So if those type of data is coming, imagine millions of people accessing one website, the clickstream data itself will be huge. And if somebody want to do a marketing campaign, okay, I purchased these goods from this market, and my segment is I'm a salaried person, and this is what I bought. So you want to run a promotion tomorrow for my type of category people, and it is real time. Now it is not waiting for some time. It is all real time that data comes. So this data will be pulled out in real time, and it will be pumped out to the front end, giving advertisement campaigns, promotions, all those things. That is one model. There are other churn models which happens where you will get advertisement campaigns on specific specific offers, like you buy all these things, you will get one free. All these things are done using big data systems in the back end, using either one of these technologies. Okay, I'm not sticking on to these technologies, but majority of the cases, whatever I have seen, this is the technology they are using in the back end, which is massively parallel processing appliances. Now we have cloud. As I told you, Redshift is one of the best technologies in the market by AWS, but the backend of it is using Postgres. So Postgres is a database that is using. So whatever queries, whatever DMVs or management queries you have to use for this, it is the same in Redshift. Okay. So if you're trained on Postgres, you can actually work on Redshift clusters. So this is the way it is getting executed in the backend. Now, let us say what type of, let us say you have a table which is having 1 million rows. Okay. Now in this 1 million row, let us say in these type of scenarios, number of columns may go up to 100, 150 columns. So imagine 100, 150 columns and you have million rows on the back end. Now if you put that everything in one single table and you try to query it, each time you insert a record into it, an index is getting created on the back end. The load is going up for you on the back end. Okay. Now if you have this MPP on the back end, you can actually shard this data into multiple nodes. How do you do that? Let us say, as he has told that sharding, he told, right? So you can distribute the data using partition. Instead of distribution using partition, actually you can use a specific key. That means to say, for that, when you get the data from the Postgres, if somebody is giving you a transactional data and you want to create this, first thing what people normally do is that they do a data profiling. Take that full data down and do a full profiling of it. So profiling is nothing but a statistical analysis of each and every column. So these 150 columns will be statistically analyzed. What is the count, individual count of this? What is the distinct count of this, each of these columns? Are they spread across evenly? So if you take 20%, one column, let us say the product, let us say milk is 20%, butter is 30%, other products is 40%. Likewise, if it is properly segmented, you can actually distribute this data based on that key column. So that exercise is one of the key things deciding what type of sharding strategy you have to take up. Hope I'm making clear. So in that, the first one is round robin. So if you don't know, first you are a starter, you are starting with a single node system, you can go for round robin. So the system will itself automatically allocate the data across these nodes based on how many number of worker nodes are there. Okay, you don't have to worry about it. You have to mention that it is round robin. It will shard the data across the nodes. Now the hash space, you have to clearly tell, this is my column, this is what I wanted to distribute the data across. But you have to be very careful. There is skewness that can happen because of that. Why? Because if one node has got 80% of the data, then this whole process is gone. Because the entire compute power will be on that 80% data and that node will be choking. So placing the data across these nodes itself is it's a very intelligently done stuff. You have to do a data profiling, understand the data, and that data is used for your AI ML algorithms. AI ML algorithms cannot work on backbone. It needs data. So it's all big data which is coming from the backend. How the data is placed on the backend, for daily processing of this or scheduled processing of this data for AI ML algorithms, if this is not properly done, there is a problem. Because you might have committed to your customer that I am going to give you the AML output within 4 hours. But this query is taking 8 hours, there is a problem. Why? Because you have not done this sharding properly. So all these matters when you set up a PostgreSQL Citus-based architecture for distributing the data across nodes. Okay. So these are the various, you can have custom placement rules also. You can write your own query and place it, give the range, and you can put the data which you were telling. So, and dynamic monitoring and adjustment of shard placements to maintain balanced load. So it has its own mechanism to dynamically analyze the sharding or the distribution across the nodes, and it will itself adjust the distribution. Okay. So how does round robin work? So round robin, how it works is that it randomly takes any of these nodes. Let us say it has got 60 nodes. In the 60 nodes, it will randomly take all the nodes and start assigning the distribution to all those tables. So the creation of the table itself is very important. So I'll show you that how to create those tables. So you have to clearly mention what type of distribution strategy you are following for that table. So even, for example, if you have a currency table which you want to join with any one of these large tables, you can actually replicate that tables across these nodes, so that when you join it for any of the purposes, that join will efficiently work. If, let us say, if you have stored it only here, that currency table, what it has to do? It has to transmit by a network to all the other nodes where you want to join. That kills the time. So you can actually replicate the data across these nodes so that the query becomes much more faster. That also is a strategy you have to follow before doing creating a database structure using data profile. Okay, so then hash actually creates the exact location. So where the table has to be given, it will create it in that exact location. So it will correctly put in the three sections of the worker nodes. Okay, so let us say joining these hash tables, right? So if you are joining these hash tables, you have to be very careful that these keys, the types of the product key is an int on both the sides. So when you're joining it, you make sure that the data types are same. If you are trying to do any type of casting, it is a problem. So you have to be very careful when you design the database or the table. If you want to join something, make the data type the same. So in the data modeling, there is an exercise called as data modeling before building or loading the data to the these type of systems. During that time, you have to make sure these keys are going to be equal. So then it will work. If it is different, there is a problem, because the query execution time will be much bigger, and the time it takes to return the records to the front end will be a big problem. So then you have the distributed joins. So you can, as I told you, co-location or replication, you can have data movement techniques, which you can move the data across the nodes. And then co-location strategy, so you can have the same data stored, related data stored on the same nodes. You can store the data, and it maintains ACID properties as such, but a transaction-oriented system is not recommended for these type of distributed database systems or Citus systems for Postgres, because transaction-oriented system is not recommended to this, because this is for high volume insert. See, even you can use a copy command using a, let us say, 1 GB CSV file, directly insert into these type of tables without any index. The good part of it is that you do not create an index on the backend. You can just put it in a shared drive, and you can get the data from there, and you can directly insert bulk in fraction of a second. It will go inside. But if you're doing it via an insert command using a normal staging table and putting it, it is a row by row insert, and it will take time, and the index will go up. So ACID properties to commit protocols are there. It is okay, but it is not recommended. And it has got various UI. Citus has got UIs where you can actually interact with the entire ecosystem and see what are the worker nodes. It has got its own database queries. We can see what is the health of the worker nodes, what is the memory utilization of each of those nodes, what is the CPU utilization, which query is killing this whole process. You can have the execution plan. You can see what is execution plan, how much cache is left on each of this execution plan. All those things you can manage and see from the Citus user interface. So this I'm just skipping. So you can create the tables like this. Create table, distributed table, and you can give which is the distribution key you can give. So it will create those tables across these nodes. So it is fairly simple, but the main problem is with the infrastructure and the configurations of the system. So installation and configuration and the VM setup or the compute setups cannot be done by a starting guy, because it is slightly complex. You have to set it up properly, because it is called an appliance. It is not just a database you go and spin it up. It requires professional services where you have to spin it in a proper manner, and it is not that you are going to spin 5 nodes and stop it. The purpose of these type of architectures is that it will scale. Today it is 5 nodes, tomorrow the customer will come and tell, because this data will never be archived. This is called a single source of truth for the company. So the company will tell, I want this as a single source of truth for anybody and everybody coming and asking for any data. I should be able to see it on whichever year, whichever country. So we have done it for some companies for 120 countries. Currently, we are doing it for North America using Redshift, Postgres. So it is like, no, they will not allow the data to be archived or deleted. The data should be there. So it is not going to decrease. Whenever you spin one cluster like this, it is going to increase only. So when you spin it, you have to be very careful that the nodes are configured properly and it's not choke the system. Now, let us look at some patterns and practices. So why should anybody use this? As I clearly explained, it is for improved query performance. The query needs to be performed properly, and it should return the data quite fast. And linear scalability, it should linearly scalable. And real-time analytic support. You should get the real-time analytic support. You cannot tell the customer it will take 1 day to process and come back. It's not going to work out. They will not wait for it. They want it instantaneous because the technology has gone leaps and bounds, because the appliances and the machines that are being built for these type of technologies are very advanced nowadays. They use even bubble memories for storing these type of systems. Technology has also grown very fast. SSDs are used, and it is called just a bunch of disks. So performance monitoring tool also available. Now let us compute consumption pattern. So if you have telemetry data, what is the pattern you have to follow for this, right? So if you have the telemetry data, the data is normally streamed. As he was telling, it is Kafka or even Hub or MQTT, Mosquito servers. So if the data is coming in a telemetry manner, first it has to be persisted somewhere. So it will not directly go to the MPP system. It will be persisted somewhere in the storage, but it is real time. It will just come, the JSON file will come and land in that persistent storage, and then it will go to the database, PostgreSQL database. Then it will export, and it will go into another database where it is a data mart, and then it will go to the app. So normally nobody directly queries the database. It will always be a data mart or a data ODS, operational data stores, for each and every department, for each and every country. So there are systems available when you spin up this Citus architecture for an enterprise scale, for, like I say, railways, Indian Railways. If you are putting that, for each and every state there will be ODS. For each and every operations manager there will be ODS or a data mart. They will not directly give access to the entire distributed database systems. That might be requiring the protocols and permissions and racing tickets, and all those things will come. Then only it will be accessed completely. And no data is lost. It is stored in a type 2 type of a data, where old record becomes inactive and the new record becomes active. So if the same record is coming again, there will be duplicates on the back end, but it is not deleted. The data will be there in that back end. So it will always be, for an app layer, front end layer, it is a data mart, and it will be pushed into the front end layer. Okay, this is compute consumption pattern. And next is SaaS customer isolation. As I told you, if there is a clickstream data, if the data is getting pumped on a real-time basis to the database using a persistent storage and via IVM, some nodes will be used for customers and some nodes will be used for the corporate. So it will be, again, nodes will be split inside that. It may not be equally distributed. So some of the nodes will be for a role-based access control or whatever it is, it will be given to the customer front end. Others will be used for the corporate node. So this type of pattern also is a viable option. Instead of spinning separate databases for each one of them, you create separate, in the same infrastructure, you can have the nodes configured for separate people based on the access grants. Okay, so what are the sizing factors which you have to take care of when you do that? You have to look at the database capacity. First of all, what is the capacity you are looking at for the next 5 years? What is the database growth? What is the data volume growth? You have to have an estimate of that. If there is large amount of data which is stored in the temp DB, you have to take care of that because the queries will be pumping data into that as a temporary storage. And concurrency and memory. So how much memory you needed, how many people are going to access real time, how many people are going to sometimes access. For example, AI ML people, machine learning people may not access every time. They will just take the data for 1 month and do the churn modeling and then push the numbers out. And then load, no. So, and the load, what is the load to the system? And what is the transaction size you are looking at? And the memory management. So how you are going to manage the memory. Memory is one of the key things. So, some of the notes is that choose a column with high cardinality when as a distribution column. So where you are using a large amount of joins. So for example, in a where clause, if you are using a where clause multiple times in the query, then it is better to use that as a, if you are using that as a predicate, you have to consider it for a distribution column. Then with an even distribution, that is, of course, it has to be an even distribution. It cannot be like a jumbled up because the skew will come and the query will create problems in the backend. Distribute the fact and dimension tables on their common columns. So you have to distribute dimensions. You may not have to distribute dimensions. You can actually replicate it. You don't have to distribute it, but fact has to be distributed, but you have to be careful with that. Because it will be huge tables. It will be huge, massively huge. Like today I'm getting within 1 day 6 crore records only from 10 locations. So imagine what will be the scene in within 1 month. No? So this is the volume if you are going into data and AI as a career. You are going forward. The volume of data will be very huge, and you should be able to manage it. So it is not that an easy task because things will get choked sometimes. So there can be reference tables for dimension tables also. Okay. So how do you size it by capacity? Just a guideline which may vary from technology to technology. Okay. So it can be a 1 node, 2 node, up to 60 nodes you can have it, and then you can estimate the number of TBs you can store. What is the TB you are looking at? 160 TB, 300 TBs. So even Mintra is while I was migrated, it is around 350 terabytes of data. So we used even 300 node cluster to run that system. So this is very important for you because you have to size it. What is the size and what is the node count? It has to. There are tools available in the internet which you can use for that. Okay, so there is HP sizing tool. You can search for it. You can find it. Sorry. Yeah. So it is always better to do bulk load via files rather than using a row by row insert. So if in a Citus or a Postgres distributed database systems, if there is large amount of volume of data need to be loaded, always recommend for a CSV delimited file upload or some other file format where you can have a copy command. You can just copy the entire data directly into a table. You don't have to do a row by row insert. It will just push the complete data into it. And the only challenge you'll be facing is with the data type mapping. So once you have that data type mapping exactly in the CSV and the table, it will go within a fraction of a second. Because that's very important. The ETL which he was telling, if the ETL is taking time, everything kills. The numbers are not out. Next morning, where is the number? No, it is not coming. ETL is running, sir. No, then why did you build the system? So this is very important, especially with the clickstream data or large enterprise data which is coming from SAP or marketing data or whatever, or telemetry data which is coming. This is text file data will be, this can be stored in any cloud storage. It can be stored in Azure, it can be stored in Google, Amazon, or any other cloud storage. You can store it and write the copy command and the data will be inside your system. Okay. So, and also compressed text, don't compress the file. So if you compress it, there is a problem. Don't compress it. But there are compression available .gz files. Specific compressions are there, but it is recommended not to use the compression technique. And split data across or use different files. So you can also estimate on each node what is the count of readers and what of count of writers. So if the if you look at here, the count in the node 1, 8 readers are there and writers are 60, but the writers are all constant here. Now you have to take it in such a manner that you have to make static the number of writers, make it static. Tell them, no, these are the total number of users you can log into the system and write into the database. Because data warehouse is pumping data into it on a very large scale, you cannot go and write anything into it. Only the ETL can go and write into it. So you have to restrict that based on the size of the nodes. But the readers you can have, scale it up. There is no problem with that. But writers has to be constant when you are designing the system. Okay, so this I told you, a compiler cannot be read in parallel. So parallel reading is one thing. The same CSV file, let us say you have 10 CSV files and you wanted to load these 10 CSV files, 10 million each rows, you can load it parallelly. You know, parallelly you can load it in a fraction of a second, the data will go inside the Citus. But if you look at any other database on a standalone mode or a single node cluster, it is impossible to do it. But if it is distributed, you can do it as a parallel load millions of rows in fraction of a second. It will go inside. And no index also, that is the best part of it. So these are the challenges you face: scalability management, consistency challenges, latency and fault tolerance, and transaction management complexity. So transaction management complexity, I recommend don't use OLTP transactions for this database. Use for OLAP or those type of systems where analysis is needed, or data warehousing denormalized structure is better recommended for Citus based distributed databases. So there are various tools available. Datadog is available, Vivid Cortex. All these are tools available in the market where you can go and see the performance of this. So these are not recommended by me. This is the research that is telling. If your company does not allow you to do it, don't do it. They will have their own monitoring stuff on the database, so they can use that also. I think IITM Pravartak is coming up with a monitoring tool. Congrats to it. So that will be a very good thing for monitoring the worker nodes as well as all the memory and CPU consumption. So there are 4 items you can. Supervisor role is there, aggregatory sale, operating system metrics, and PostgreSQL metrics. All these data can be monitored from the monitoring system. So regarding the security considerations, while setting it up, you have TLS, you can do that with self-signed certificate. So, but this will help only in eavesdropping of network. So I told you there is, within the worker nodes, there is a network running. So for standard companies like Microsoft, AWS, their networks are custom built to take up the speed of the data transfer. The moment this chokes, everything goes for a failed customer complaint. So that networks are very, very efficient networks. There is a specific name for that, I forgot that. So this data encryption of TLS will help the eavesdropping on the network. If somebody wants to look into what is happening in the network packets, that can be blocked using TLS. And other ones like man in the middle attack or something, packet sniffing while the data is on the network, on air, that you have to do SSL mode. SSL certificate has to be installed, and then only it will work. And you have to set up that SSL mode it will require. You need a server certificate also for that. Access control, you can have role-based access control for each one of these using grants in the table. You can give grants you create various users inside the database, and you can give grants to those. Auditing and monitoring, you have specific tools. There are specific DMV queries for the databases, for the database administrator, which they can query and see. Authentication integration, so you can set up during the startup of the server this file, hba.config, and you can configure all the things for that. If somebody wanted to make a MFA, multi-factor authentication, or MSAL, Active Directory based, or Google authentication, you can actually go and configure it from here with the IP addresses. So all these securities are needed because when you are setting it up, they will ask, there will be an audit going on, and they will audit it whether these all are there. Otherwise, data is lost. So this is one of, since I'm ex Microsoft, so this is Azure Citus architecture, where they have come up with Azure Cosmos as a no Azure Cosmos is a platform for Citus, but it is using Postgres, SQL, and extensions on the backend, and it has got a VM. Kubernetes cluster is used, and Docker container is used for this. And there is, you can add multiple nodes to it. And the good part is it is premium SSD, and there is a blob already attached to it. So the non-SQL, non-unstructured data is already stored inside. You can easily access it from there. Also the files, whichever it is, right? So this is how it is, how you run a query. So if you wanted to create a table campaign, select create distributed table, and you can the table will be created across these nodes, the same as what I showed you previously. So these are some of the customers where we have implemented distributed database systems for across various regions. So all of them are using big data clusters. It is not OLTP systems. So so the matter of the fact, what I'm telling is, it is a very it's an extremely growing market. So soon as Postgres comes up with architecture, lot of possibilities are there, and there is a new career will open for any Postgres guys who wanted to focus on this, especially if they are doing this. Yeah. Any questions now?
Just one question regarding round robin. Two questions actually. The first question relates to round robin. And in case of round robin, if you want to shove the inserts into multiple shards on different worker nodes, you don't have stickiness because you don't have a distribution column based on which you're doing the round robin insert.
Yeah.
So you'll have to send the query to all the nodes simultaneously in order to get it out.
Yes. It's a random choice. It's a random choice by the controller node.
Random choice by the controller node, yes.
But it's a round robin. There is an algorithm inside that.
Understood.
Yeah.
But there is no stickiness involved here. In the case of hash, you hash the distribution column, find out which is the shard number it's going into, and you route the request to that.
Correct.
Right?
Yeah.
So isn't round robin a very inefficient mechanism?
It's an inefficient mechanism, sir. That's the first statement I had. It is used for single node cluster.
Correct. So it can be only for a single node cluster with all the shards of the same.
Yeah.
With all the shards in the same cluster.
Yes.
But if you're looking at multiple cluster nodes,
yes,
it's not an efficient mechanism.
No, it is not at all an efficient mechanism. It will create problem.
Correct.
Skewness will happen.
Yeah, that's the point I wanted to make. The second one, with regard to the hashing, you said you can take the entire file and then do a copy of it and dump it into any single node.
Yeah, that's a staging table. Yeah,
it's a staging table.
Yeah. Before inserting in the main table, you just park it there.
Oh, so the staging table sits on the primary coordinator.
Yeah.
It doesn't go to the worker node.
No, it can be round robin, but we'll delete the table. Once it is inserted, we'll drop the table. See, we take the data, dump data, let us say 100 million records, put it into the...
But you'll have to run the distribution column through the hash function to figure out which shard it has to go into.
Yeah.
Which node.
Yeah,
that is done. Correct?
Yeah. That is a main table that is created.
Right. So, yeah.
Without that, it is a failure.
Without that, it's a failure. It's
yes.
100%.
Yeah.
Thank you.
Sir, sorry.
Yes, suppose any node goes down, so how you handle that scenario, like what is the recovery mechanism?
So node going down is a big problem. So node going down means that node's data is not available.
Yeah.
So you have to recover. So the node can go down only because of that VM or that machine which has got a problem. Otherwise it will not go wrong. right? So it is, you have to make sure it is never going around go down. If it goes down, there is a problem with that data.
Suppose if that happens, then in that case, what is the mechanism to handle it?
You have to send a mail that no, this node is down, we need time to recover it,
Okay.
because the VM backup always has to be taken
Okay.
every day, or no, the VST backup has to be taken to the storage and you have to recover it.
You could also run DR side and do stream replication on the main side to the DR side, so that it can take over the queries.
Sir, in this case, DR is not preferred because the distributed database system DR is quite complex. It is not that as straightforward as what you do in a single node or a single VM, because we are talking about 30-40 nodes, and DR means you have to shut down all the VM, and let us say it is a geo-redundant cluster. You have in one region you have these 30 nodes, and another region you have spin another 30 nodes. Okay. Now, if you are failing it over from here to here, first of all, you should have a high availability to that system. There is a replication or a high availability which will be running to that. All the logs has to
There
be.
are products in the market that basically run something like a HA proxy or a proxy for
Yeah.
load balancing.
Load balance.
And they load balance the read queries between the DR site and the main site.
It does that. It
Right.
does that. It does that. But first of all, you need a TCP/IP listener for it. You know, this that needs to be configured for both the clusters. It cannot be for one. You cannot have one URL for one cluster and another URL for another cluster. It has to be one single URL for the load balancer to get the data. For in this case, if it is 30-40 nodes that is running, and the controller node is 2, then it is difficult to manage it. It will be very hard to take the DR site up and all. It will take time.
So you're suggesting that there's going to be a primary controller per site, one single controller per site.
Yeah.
But you can also have something like a standby controller,
You can have it, but configuration.
which you can sync up with the primary controller with regard to the metadata.
Yeah.
You can still go ahead and do the collation of the queries
Yeah. You can
on
do
the
that.
query controllers,
Yeah.
on the sub-query controllers, rather than on just a single primary controller. There are architectures in the market for
Yeah.
that are doing this.
Yes, you can do that, but still DR side I'm not sure, sir, because this is large amount of data. Recovering itself, it will take time, days it will take. Recovery of the database, or if you don't have the VM backup, and VM backup restoring itself, will be taking some time. So what you told is a good point. You can have multiple master control nodes, but I have not worked on that.
Okay.
Yeah.
So all nodes should have the same type of configuration, or it may have the variation?
It can have various configurations. And everything is available in Citus architecture, or queries are available to spin that. You can add the nodes from the query itself.
There's one question regarding columnar storage.
Yeah, column store index.
Storage. I think it's being worked on. Marco Slot is actually
Yeah.
was responsible for bringing it out from Microsoft Citus. So I was just wondering, how common is it that columnar storage gets deployed as a default mechanism for storing certain data? Or is it the default they go to, or do they have specific requirements based on which somebody recommends, saying that columnar storage is what is useful for this application? And in the question you talked about compression also, right? In columnar storage, they compress a lot,
Yeah.
right?
Yes.
So I was just wondering.
Compression. I talked about the file, not the table. I'm just correcting you. The file, which is a copy command. Compressing is the
that's
problem.
just for the copy command file.
Yeah.
And not for the actual table itself.
No.
They do compression on tables itself.
Yeah, that you can do. That using that using columnar's index, you can do it. But default columnar indexing is recommended for large tables.
Right.
Yes, that improves the storage also, the compression also.
But you shouldn't have any updates and deletes, because Citus supports only append only
Correct. Yeah.
for columnar
Yes.
storage.
Yes.
Right. Thank you.
Yeah. There are no other questions. No challenges. That's the whole point of this architecture.
Using the Citus and Redshift you are using.
In the Redshift or Postgres class, this distributed database architecture. The whole point is to increase the concurrency, but concurrency for write you have to fix it. You cannot give unlimited number of writes on the concurrency side. Read you can have, there is no problem, because the whole point of that is the read. It's an analytical workload, because once you implement the column store index, analytical workloads will be very fast. You write the query to get a join or anything, it will fly. Concurrency won't be a big problem.
I just want to know the opinion of the Nirmal sir on this.
Yeah.
EDS. How you can take up these things in your factory setup or something like that? What will be your
Yeah, actually, if we are given a choice, we would love to take it. The only problem is the cost. Like you are showing like hundreds of nodes, right? Like that kind of infrastructure is not something available in the factory setup. Like when manufacturers are realizing the importance of this such a digital solutions and the capabilities of this, and they want to give that investment. Eventually we want to do this because it will unleash lot more capabilities than what we are able to do with the data. Today it's like what we are doing is whatever is capable within the given compute. Like this will really remove that limitations, and we can do certain advanced analytics and find some other patterns like which is not known yet. All those things we would do, some deep neural network, all those things. But really that is a constraint today we are having. And we are also having a SaaS offering, like the same product we are offering as SaaS. So there we are planning to introduce this DistDB concepts there and make use of these things for the advanced customers. So right now our focus is more for equipping all our MSME customers. So when some really big enterprises are interested in utilizing our solution and want these capabilities to be added, so we want to take it up there.
Yeah. So we have done this for Hindustan Coca-Cola beverages factory in Bidari. So there these type of implementations are needed. Any other question? Thank you.